We are going to get into trigonometric identities. So I will forewarn you, there's a lot of memorization in this particular chapter. So I would start making cards or however you memorize stuff now, because you have a lot of identities by the end of this chapter. The first one's very simple. These are called reciprocal identities. You are familiar with these because of right-angled trigonometry. So the reciprocal of sine is cosecant, meaning if you have the sine, all you have to do is flip it upside down to get the cosecant. Cosine is reciprocated with secant, tangent reciprocated with cotangent. And then, of course, the bottom three are just the opposites. Cosecant is the reciprocal of sine, secant reciprocal of cosine, cotangent reciprocal of tangent. We know those. Those are ones we've used with right-angled trigonometry. Quotient identities are also somewhat familiar because of the y and x. Tangent is your sine over your cosine. We've done this with unit circle. Cotangent is cosine over sine. So all of these identities we have done before. So we are starting with easy ones. Let's look at how we use these. So look at the first example. Use reciprocal and quotient identities. In example 1, it says if the cosecant is 7/4, find the sine. This is rather simple. We know that the cosecant is the reciprocal of the sine. So if we have the cosecant to find the sine, we just flip it over. So the sine of this is going to be 4/7. Very easy. All right. Quotient identity. B, if the cotangent is 2/5 square root of 5 and the sine is square root of 5/3, find the cosine. Well, we know that the cotangent is the cosine over the sine. So we can literally fill in what we know. Cotangent is 2/5 square root of 5. Cosine, we don't know. We're solving for. Sine is square root of 5/3. We're just going to solve for that. We're going to multiply both sides by the reciprocal here. So multiply both sides by, actually we don't have to multiply by the reciprocal. Square root of 5/3, because that's on the bottom already. Multiply by square root of 5/3. We will get the square root of 5s here will cancel out. So square root of 5 cancels. That means the cosine of x is going to be 2/15. If the secant is 5/3, find the cosine. You should have just gotten 3/5 there. If the cosecant is 25/7 and the secant is 25/24, find the tangent. 7/24. 7/24. With these identities based on the Pythagorean theorem, we will use them so often you will probably memorize them naturally, but I would say write them down and memorize them. So they're based off of a squared plus b squared equals c squared, but you want to memorize them. Sine squared plus cosine squared is 1. Tangent squared plus 1 is secant squared. Cotangent squared plus 1 is cosecant squared. So let's look at how we use these. Using the Pythagorean identities. If the tangent of theta is -8 and the sine is greater than 0, find the sine and cosine of theta. All right. So it's important that we know this, that this particular one is positive. Sine is positive. Because if the tangent is negative, that tells us what about the cosine? If I know the sine is positive, but the tangent is negative, what do I know about the cosine? It's going to be negative. So in my final answer, I'm going to have to pay attention to the fact that this right here is going to be negative. Because I'm always going to get a positive using these because it's Pythagorean identity. So I'm taking squares. All right. If I have the tangent, then I am going to solve for secant. Secant is going to help me with tangent because I will have the reciprocal of my cosine, right? So I'm going to use my Pythagorean identity that deals with my tangent. My tangent squared plus 1 should equal my secant squared. All right? And so I'm going to fill in what I know. My tangent, -8 squared plus 1 should equal my secant squared. And then I'm just going to solve. -8 squared is 64 plus 1 is my secant squared. So 65 is my secant squared. So the square root of 65 should equal my secant. All right, I am looking for my sine and my cosine. My secant helps me find my cosine, right? So now I'm going to use my reciprocal identity. How do I find my cosine if I have my secant? I have my secant, I need my cosine. What do I do with my secant to get my cosine? Yeah, reciprocate it, just 1 over. Is it going to be my positive one or my negative one based on what I decided up there? Negative. So my cosine is going to be negative 1 over the square root of 65. Now remember, we don't leave it like that, right? So what are we going to do with that guy? Yeah, top and bottom by the square root of 65. So my cosine is going to be negative square root of 65 over 65. All right. So I have solved for my cosine.
So
all right.
why is the cosine?
Now I need to solve for sine. I currently have my tangent and my cosine. Tangent is sine over cosine. So I am just going to solve for what I need here. So I'm going to say, well, I have tangent. My tangent is my sine over my cosine, and I still need to solve for sine. So I'm going to plug in what I know. Negative 8 equals sine over cosine, which is negative square root of 65 over 65. So I'm going to multiply the top and bottom by the negative square root of 65 over 65. So my sine then is going to equal 8 square root of 65 over 65. So I've solved for my sine and my cosine. And I can double check this by doing sine squared plus cosine squared equals 1, by the way, which is what they did with the check. They took, I'll just show you how they checked it really quickly. Sine squared plus cosine squared equals 1. And so I would have 64 times 65 over 65 squared plus a negative 65 over 65, right? Squared. And if you look, if I canceled this, I would get, well, that's going to be positive because I squared it, but these are going to cancel. 1 over your 65 will cancel. So I get 64 over 65 plus 1 over 65 equals 1, which is true. So anytime you have sine and cosine, you can actually check it and make sure. Let's look at these together. So they want you to find cosecant and tangent given cotangent and telling you that the cosine is less than 0, all right? So cotangent to tangent is easy. If they want me to find tangent, that's the fastest one here. If I have the cotangent and I need to solve for the tangent, I can just reciprocate it. Those are reciprocal identities here. So tangent's very simple. The tangent of theta is just going to be the reciprocal of the cotangent, so negative 1/3. So that is there. They want me to find cosecant. And all I really have is my tangent and my cotangent. So I'm going to use my Pythagorean identity that deals with cotangent and cosecant. So I'm going to set up my cotangent squared plus 1 should equal my cosecant squared. Now, here's the deal. I know that my cotangent and my tangent are both negative. I also know that my cosine is negative, right? Which means that my sine is positive. If my sine is positive, so is my cosecant. All right, so I know that this right here is going to be a positive because my cosine's negative, but I have a negative tangent. All right, so I'm going to plug in what I have here. I have my cotangent. My cotangent is negative 3. Negative 3 plus squared plus 1 should equal my cosecant squared. All right. Negative 3 squared is 9 plus 1 equals cosecant squared. So I have 10 equals cosecant squared. How do I solve for cosecant? Square root. And I know it's positive because I've already figured that out. So the cosecant theta equals the square root of 10. So I have that. And my other question was this one. So I have both of them solved. All right, so for the next one, I have cotangent and secant that I'm trying to solve, and they've given me sine. All right, they've given me sine. For this one, I can reciprocate my sine and get my cosecant, right? So I can say, if I know my sine here is positive, they've also told me my cosine is positive, which tells me my cotangent is going to be positive. So this is positive, my cosine is positive, which means my cotangent is going to be positive, and my secant will be positive. So I know all my answers that I'm looking for are going to end up being positive. All right. I am going to start with reciprocating my sine. So if I reciprocate my sine, I get my cosecant. So the cosecant of x should be 6. And that will help me find my cotangent. I'm going to use actually the same identity. Cotangent squared of x plus 1 should equal my cosecant squared of x. All right? And so I'm going to fill in what I know. I know my cosecant, which is 6. So I have this set up. Cotangent squared plus 1 equals 6 squared. So that means the cotangent squared plus 1 should equal 36. Subtract 1. Cotangent squared is 35. So cotangent here is going to be the square root of 35. All right. If I'm trying to solve for my secant then, my secant, I can reciprocate this cotangent and set up my tangent squared plus 1 equals secant squared. All right, because I'm solving for secant squared. And so I can actually just use my other Pythagorean identity if I want to here. So I know my cotangent is square root of 35. So I know my tangent then. So if I go back to this one, tangent squared of x plus 1 equals secant squared. I can just reciprocate this guy and plug it in. So 1 over the square root of 35 squared plus 1 equals my secant squared. And just go ahead and square it. 1 over 35 plus 1 equals secant squared. Get a common denominator. This is going to be 35 over 35. So I get 36 over 35 equals secant squared. Take the square root. Square root of 36 is just 6. Square root of 35 we don't have. That should be my secant, but of course I don't want to leave it like that, so I'm going to multiply the top and bottom by the square root of 35. So I should get that my secant here of x is 6 square root of 35 over 35. All right, so the first thing we're going to look at is something called cofunction identities. Cofunction identities. So if you recall in right-angle trigonometry, what we found was that if I were to take the sine of this angle alpha here, so if I were to say the sine of alpha, that is going to be the same thing as the cosine then of your beta. And so, for example, if I have a 3, 4, 5 triangle, so let's say I have, and we'll just actually do it using this one. So let's say this is a 3, 4, 5 triangle here. All right. My sine of alpha is going to be opposite over hypotenuse, right? Opposite over hypotenuse. So sine of alpha here, based on what I just did, would be opposite over hypotenuse. Cosine of beta is adjacent over hypotenuse. So you can see that when you have a right angle, your angles kind of correspond to each other with their sine and cosine. All right? Something else we know about those two angles is they are complementary, right? All three angles in a right triangle add up, or any triangle, add up to 180, right? We already have 90. So these two guys always add up to what? 90. So if I want to find beta based on alpha, I just say 90 minus alpha, right? So I can actually replace this beta here. I can say, well, that's the same thing as 90 minus my alpha, right? Because they're complementary angles. And so what you'll find with your cofunction identities, it's based on that concept there. If I have the sine of some angle, it's the same thing as 90 degrees or pi over 2 minus that angle. So the sine and cosine relate to each other if you are subtracting from 90 degrees because they're complementary angles. All right, so the sine of one angle will equal the cosine of its complement. The cosine of its complement. Same with cosine. The cosine of one angle will equal the sine of its complement, pi over 2 minus that angle. Pi over 2 is just 90 degrees. All right, tangent and cotangent relate to each other the same way, and secant and cosecant relate to each other the same way. These are called cofunction identities. Cofunction identities. This sometimes helps when you have when you're solving from problems. So we're going to do it with a little bit of angles that they give us here. But sine and cosine relate to each other as complementary angles, tangent and cotangent, and secant and cosecant. All right, so you can just take, if you're finding the sine of one angle, you can just take 90 minus that angle and get the cosine, or pi over 2 minus that angle, depending on if you have it in radians or degrees. That is your cofunction. Let's look at even and odd functions. Even and odd, middle of page 314. Middle of page 314. All right. So with this, they're showing us a unit circle here. And so I have this angle alpha, and I have its sine and cosine. Sine is the y value, cosine is the x, right? And then I have negative alpha. I took the same angle and did negative, right? I have the sine of the negative y and the cosine of the x. You'll notice that the negative angle affected the sine, right? My y changed from positive to negative, but changing it to a negative angle did not affect its cosine. The cosine stayed the same. Does that make sense? So going up or going down did not affect the cosine. It affected only the sine. Now, because it only affected the sine, it also affected the tangent and the cotangent. So the cotangent and tangent would go from positive to negative as well if you did a negative sine, a negative angle. All right? So if, let's say I go up 30 degrees, my sine and cosine are both positive. If I go down 30 degrees, I'm going to have the same numbers, but my sine is now negative, right? Up 30 degrees, my tangent is positive. Down 30 degrees, it's going to be the same exact number, but it's going to be a negative tangent. All right? And so that's where you get these even and odd properties here. The sine of a negative angle negates the sine itself. The cosine of a negative angle does not. So you see how the cosine of a negative angle and the cosine of the original angle are the same. Tangent negates, right? So your sine and your tangent negate, as well as your reciprocals of those, cosecant and cotangent. But your cosine and your secant do not negate if you negate the angle. Those remain positive or remain whatever it was. All right? And so those are called your odd even identities, your odd even identities. Let's look at an example of how we use these. How do we use these? Use cofunction and odd even identities. All right? It says, if the tangent is 1.28, find the cotangent of theta minus pi over 2. Theta minus pi over 2. My cofunction identities are not the angle minus pi over 2. It's pi over 2 minus the angle, correct? Yes? So I'm going to rewrite this. I'm going to say cotangent of negative pi over 2 plus theta. Okay? So far, so good. All right. And then I am going to pull a negative out. All right, I'm going to pull a negative out. And so I'm going to say, well, the cotangent of -1 times pi over 2 minus theta, right? So far, so good. Now, I have the cotangent of a negative angle. The cotangent of a negative angle is the same thing as the negative cotangent of that angle. If you look at your odd, even identities, the bottom right corner of them in your book, odd, even identities, from those we know that if I have the cotangent of a negative angle, it's the same thing as the negative cotangent of that angle, okay? So I can actually take this -1 and just put it out here. So that's the same thing as negative cotangent of pi over 2 minus theta. Okay? Yes? Now, look at your cofunction identities. Your cofunction identities. I know that the cotangent of pi over 2 minus some angle is the same thing as the tangent of that angle, right? Does that make sense? So I can replace this piece of it with tangent. Tangent of that angle and bring that negative down. And they told me what the tangent is. So up here, they told me the tangent is 1.28. So I can take that 1.28 and I can plug it in for tangent. So I get negative 1.28. This should feel almost like a proof. All right, this should feel almost like a proof from geometry. You had to walk through your steps to get down there. You couldn't just assume you were going to get the negative answer, because there are times with cosine, it's not going to be the negative answer, all right? And so we didn't have exactly what we needed. We could move it around, take a negative out, replace it with an identity, because an identity told us we could do this. Replace it with another identity, because we had another identity that told us we could do this, and then we found our answer. So go ahead and try guided practice number 3. Guided practice number 3. So if you look at this one, the cosine of x minus pi over 2, we had to pull a negative out and make it the cosine of pi over 2 minus x, which is what we were looking for. The cosine of a negative angle doesn't change, so it's the same thing as the cosine of the regular angle itself. This is your cofunction to sine. So cosine of pi over 2 minus x is the same thing as sine of x. And they already told us the sine of x, so it was negative 0.37 as your answer. If you go back in your brain, like when we started combining like terms in algebra, it's not like you were going to have x equals 5 as an answer. You would just combine like terms and get it as simple as possible. And so with these, you're simplifying. And one of the ways you can simplify is in this example, it says using only sine and cosine. Simplify using only sine and cosine. And then once you do that, you can potentially simplify it further depending on what you have. And so a lot of times sine and cosine will help you get out of the situation, like get it simplified, because those are your two basic functions that everything else is based off of. And so if you simplify using sine and cosine, you're literally going to rewrite everything using those two functions. So cosecant. If I want to rewrite that in terms of sine or cosine, how am I going to rewrite that? What is cosecant? 1 over sine. So I'm going to write 1 over sine. All right. And then secant. How would I rewrite that one? 1 over cosine. And then cotangent. How would I rate that one? In terms of sine and cosine. Cotangent and just sine and cosine. Cosine over sine. Okay. So I basically have, if I were to simplify this piece, 1 over sine cosine minus cosine over sine. Okay. Now, I want a common denominator, right? Isn't that what I need here? What would my common denominator be here? Sine. So I have sine, cosine, and sine. What's my common denominator? This way. Let's say I had 1 over xy minus 1 over x. What's my common denominator?
1. No.
Common denominator.
Yeah.
xy, right? You have to have every piece of it.
Oh.
Right?
Oh.
Right, so my common denominator is going to be sine cosine, all right? My left fraction already has my common denominator. What do I need to multiply my right fraction by to get that common denominator? So I need to multiply the top and the bottom by cosine to get that common denominator, yes? Okay, so I have on the numerator then, I have 1 minus cosine squared over sine cosine. Just getting common denominator. Now, here's where you start to have these Pythagorean identities and you want to start recognizing them when they're in a different form, okay? So I'm going to write this Pythagorean identity out to the side. This is the one you're familiar with, right? Okay. Now, if I were to subtract my cosine squared over, see what happens here? So 1 minus cosine squared is actually the Pythagorean identity. It equals sine squared. Does everybody see that? And so I can replace this 1 minus cosine squared. I can replace that with sine squared. 1 minus sine squared is cosine squared. 1 minus cosine squared is sine squared because they add up to 1. All right? And so I can actually rewrite this. And I can say, well, that numerator is just sine squared of theta over sine cosine. Can I continue to simplify? Yes. How can I simplify now? Yes, I can divide sine out of top and bottom, right? So I can, if this were x squared over xy, I would simplify my x's, right? And so I can take one of my sines out up here. That's just a sine instead of sine squared. And I can take 1 out of there. And I end up with sine of theta over cosine of theta. Can I simplify again?
Yes.
What is sine over cosine? Tangent, which is my final answer here. Tangent of theta. And so this identity up here actually equals tangent of theta. That is the most simple form for that. So you want to use the same method. You want to rewrite everything as sine and cosine. All right. So for the first one, if I'm rewriting secant, how would I rewrite secant? 1 over cosine. What about tangent? Sine over cosine. And then we're going to leave sine x the same because it's already in sine over cosine, right? It's already in sine and cosine. You can write it sine over 1 if it helps you, just to see it. All right. I actually already have a common denominator, right? Both of these are already with cosine. So I have 1 minus sine squared over cosine. 1 minus sine squared. That's one of your Pythagorean identities. What is 1 minus sine squared? What can I replace that with? Cosine squared. And how do I simplify this one? I can simplify one of my cosines out. So one up here, right? And one down here. And that gives me just cosine of x, which is as simple as you can get for this one. All right. So for this one, we're going to use a little bit of a couple of different properties here. The first one, when you look at this, is going to be this guy right here, the sine of 90 minus x, sine of 90 minus x. If you look back on page 314, 90 minus x or pi over 2 minus x, that's your cofunction identity. Cofunction identity. And so we can actually replace the sine of 90 minus x with what? What is the sine of pi over 2 minus theta? So we can replace this whole thing with cosine. Cosine of x. So we would have sine squared of x, cosine of x minus cosine of x. Okay? So now I want you to look at this as though I had something like this. X squared y minus y. How could I factor that? Yeah, I could take a y out and I would have x squared minus 1, right? So far, so good. And so if I take out a cosine, I would have, not a cosine squared, sorry, just a cosine. I would have a sine squared of x minus 1. So far, so good. This, sine squared minus 1 doesn't really help me that much, right? But 1 minus sine squared would. Yes? Yes. 1 minus sine squared would actually be what? Cosine squared, right? So I can actually take a negative out. So let's say what happens when I pull a negative 1 out. So if I pulled a negative 1 out, I would have negative sine squared of x plus 1, right? And this, if I rewrite it so that I can visually see it, that is 1 minus sine squared. All right? 1 minus sine squared helps me. That's a Pythagorean identity, right? What is 1 minus sine squared? That's cosine squared. So I can replace this piece right here with cosine squared. So I have negative cosine of x times cosine squared of x. Cosine of x times cosine squared of x is cosine cubed of x, which would be my answer. All right, should have got negative secant cubed. All right, so if you look at your cofunction identities, right, the first thing you can do is you can see this guy. The cosecant of 90 minus x translates to what? Cosecant of 90 minus x is now what? Secant. So I have negative secant of x minus tangent squared of x secant of x. All right? I can take out a negative secant here, right? And I'll get 1 plus tangent squared of x. All right? This is a Pythagorean identity right here. What's 1 plus tangent squared of x? Secant squared of x. So I have secant of x times secant squared of x, which is going to give me negative secant cubed of x. So combining fractions. We've done this, but not with something quite as complicated, right? When you look at this, changing everything to sine and cosine doesn't help because everything already is sine and cosine, right? And so we are going to look at getting just a common denominator here, all right? And so if I look, my common denominator would be a combination of the 1 minus sine x and the cosine x. That is my common denominator, those two together. And so my denominator here is going to be 1 minus sine of x times the cosine of x, right? And then for the numerator piece of it, I need to multiply this left one by cosine of x, right? So I get sine of x cosine squared of x, right? And I need to multiply this by 1 minus the sine of x, right? Now, let's look at this piece right here. I have 1 plus sine of x times 1 minus sine of x. This should remind you of something that looks like this, a plus b, a minus b. Okay?
Wait, so you had to cross multiply too?
Yes, so I'm cross. Now, if I were to multiply conjugates, a plus b, a minus b, I end up with a squared minus b squared. That's what happens when you multiply conjugates, right? So this should end up 1 squared, or 1 minus sine squared, right? Does everybody see why that would happen? Okay, so I end up with, on this right here, when I multiply those, 1 minus sine squared. All right. Now, yes, so this piece of it right here can be replaced. What can I replace that with? 1 minus sine squared. This should start burning into your brain. Yes, it's cosine squared. So my numerator now looks like this. Sine of x, cosine squared of x, minus cosine squared of x. All over 1 minus sine of x and cosine of x, right? Now, numerator. How can I simplify the numerator? What can I do there? Yeah, factor out a cosine. Actually, you could factor out a cosine squared, right? I end up with sine x minus 1 all over 1 minus sine of x, cosine of x. Now, if you go way back in your memory to factoring polynomials over polynomials, all right? When you have almost the exact thing, but they're in reverse order, you can take a negative out of one of them, right? And it will flip it and put it in the order you need it in. So if I were to take a negative out of this guy right here, it would end up being a positive 1 and a negative sign, right? They would both change signs. Does that make sense? If I took a negative out of this, it makes it a positive 1 and a negative. So it's exactly what I need on the denominator to cancel. Does everybody see that? And so now I can do some canceling. I can cancel this group with this group because I pulled out that negative. What else can I cancel? Yeah, one of my cosines, right? I can cancel 1 cosine to 1 cosine. And so this whole thing simplifies to just negative cosine of x. All right. So your common denominator is what? What's your common denominator here? 1 plus sine of x, cosine of x. Your numerator here would be cosine squared of x plus 1 plus sine of x, 1 plus sine of x, all right? On this side here, when you FOIL this, you get 1 plus 2 sine of x plus sine squared of x, all right? So, when I combine these, cosine squared plus sine squared equals what? What's cosine squared plus sine squared? Or sine squared plus cosine squared? It's just 1, right? So cosine squared plus sine squared can be replaced with just 1. So I have 1 plus 1 plus 2 sine of x, right? Over 1 plus sine of x, cosine of x. All right. Simplifying the top, 1 and 1 give me 2 plus 2 sine of x over 1 plus sine of x, cosine of x. What can I do in the numerator? What can I factor out there? A 2. So I can say 2, 1 plus sine of x in the numerator. And then 1 plus sine of x, cosine of x. In the denominator, what can cancel? 1 plus, yeah? So I end up with 2 over cosine of x. What is, so here, I'm going to write it this way. 2 times 1 over cosine of x. What's 1 over cosine of x? Secant. 2 secant of x.